example now, which is the your turn recurrence relation question for 3G. So we have a sequence, much like before, x1 equals 1. Almost definitely we're going to go down to the first 3 terms. So the next term is a lots of the term before, so that'd be a lots of 1 plus 5. So that's a plus 5. Yeah. Write down an expression for the second term in terms of a. Yeah, we've just done that. Show now that the third term equals this. And, you might be able to see we've got something very similar already. So let's do this one. To get the third term, you take the term before. You take a lots of the term before, which is a plus 5. And then you add on 5. So a squared plus 5a plus 5. As far as marks come for an A-level paper, they don't get easier than that. Okay, you can get those 3 marks very quickly. Given that the third term also equals 41, so again, we know what it is in terms of algebra, now we know in terms of number, we equate the two. As much as possible, try to get quadratics set equal to 0 and then factorize if you can instead of just jumping straight to a calculator, because you often get credit for factorizing and setting equal to 0. What's that? 5 take away 41, isn't it? So minus 36 equals 0. Try to factorize if you can, especially with a sequence or series question. So anything stick out here? Minus 9 and 2, 6 and 6. What about 9 and 4? Okay, so plus 9 and minus 4. Find the possible values. So this makes me feel very confident about my answer because I've got a equals minus 9 or 4. And earlier in the chapter we might have ignored some values, but that was because they were about n and we needed natural numbers, okay, which is what we've got up here. This a is just some unknown number, okay, that forms part of the rule for connecting the terms of this series. So there we go. 6 marks, and we didn't need to do very much at all.